In this lesson, we're going to talk about adding numbers that are already written in scientific notation. How can we add numbers that are already written in scientific notation? For example, I have 1.34 times 10 to the 8th and 4.5 times 10 to the 6th. These are written in scientific notation, but they don't have the same exponent. So how am I going to make these numbers easy to work with so I can write them in scientific notation? Step 1. Change one of the numbers so that both numbers have the same power of 10. So I'm going to change one of my numbers, the exponent, I want to make them equal. So here's my hint to you. You're going to take the larger power of 10 to match the smaller number, or the smaller power of 10. So 1.34 times 10 to the 8th needs to become a power of 10 to the 6th, sorry. Well, how are we going to do that? So now I need to change 1.34 times 10 to the 8th to a power that is 10 to the 6th, because I want them both to match in order to add them. Well, I'm going to move my decimal place 2 places to the right. That will now give me 134 times 10 to the 6th. Now both of my numbers are to the same power, so now I can go ahead and add. When I add these numbers, I'm only adding the first factors. Everything is to the power of 6. I know what my number is, but I'm only adding the first factors. So I'm adding 134 and 4.5. So I'll line those up. And I'm going to get 138.5 times 10 to the 6th power. Now I look at my answer. And is this new number in correct scientific notation? Remember, our rule says it can be 1 or greater than 1, but has to be less than 10. Well, this number obviously is not less than 10, so now I have to rewrite it in correct scientific notation. So I'm going to go ahead and move my decimal back 2 places, rewrite that as 1.385 times 10 to the 2nd times 10 to the 6th. This number here became times 10 to the 2nd. Well, my rule for exponent says I just add my exponents. So my correct number is 1.385 times 10 to the 8th. So what about subtraction? Works the same way. The helpful hint, they need to both be in the same power of 10. So I'm going to convert 5.4 times 10 to the 6th. I'm going to change it to a power of 4. And I moved my decimal place 2 places to the right in order to do that. And then I'm going to line up 2.1 underneath it, and I'm going to subtract. So 2.1. And I'm going to subtract those numbers. And I get 537.9 times 10 to the 4th. Looking at that, is that written in scientific notation? No, I need to change this back. So I'm going to move it 2 places to the left. So I get 5.379 times 10 to the 2nd times 10 to the 4th. And when I simplify that, I get 5.379 times 10 to the 6th. Okay, you have 3 examples on the back of your notes, and I'm going to give you a hint on the first one. I will go ahead and change that to a power of 3, so you're going to have 123 times 10 to the 3rd plus 9.6 times 10 to the third. In the second one, you're going to move your decimal 3 places, so you're going to end up with 8,620 times 10 to the 7th, and I will let you finish that one. And in number 3, you need to subtract the first two numbers. So I'm going to change 6.77 to 67.7 times 10 to the 5th. You're going to subtract the 3.2, and then in order to add the last one, you're going to have to take the number that you got from your subtraction and change it to 10 to the third. So when you get done, you're going to end up with quite a few numbers, but then convert it back into correct scientific notation. So I've given you some hints where to start, and then we'll check these tomorrow to make sure that you got the correct answers. Okay, here are 3 got it problems for you. They don't seem too hard to do, but go ahead, make sure that you are changing them to the same power before that you add the first factors, and then convert them back into correct scientific notation when you're done, and we'll check your answers tomorrow.